Welcome to Act on Energy, Acteon's podcast where offshore expertise and innovation meets global energy insight. Hosted by a range of voices from across our global teams, we dive into the data, engineering knowledge, and operational expertise, driving smarter, safer, and more sustainable energy solutions. We act across the full project lifecycle, and we're here to unpack the ideas shaping the future of offshore energy. Let's get started.
Hello, everyone, and welcome to our podcast. Today we will be discussing mooring integrity management. Why bother? I work for Acteon within its mooring and anchoring business line, Intermoor, where I serve as the Global Director for Strategic Solutions. Our team partners with our clients and industry partners to deliver practical, reliable, and cost-efficient mooring and anchoring solutions that shorten project schedules and reduce risk. My name is Tom Fulton.
Hello, I'm also in the podcast. I also work for Intermoor and serve as one of our subject matter experts for our mooring integrity management services. I'm a principal engineer and my name is Kent Longridge.
So first, just a quick story about us. Kent and I have known each other now for over 30 years. Kent is a bit more on the analytical side and I'm a bit more on the operational side. Shortly after we met, I took Kent offshore for the first time. That was pretty fun.
Yeah.
It was on a rig move in deep water offshore the U.S. We developed a methodology for efficiently and safely deploying conventional moorings off a rig in deep water. So again, this was many years ago. It was really challenging and people were damaging the rig mooring equipment and rig moves were just taking a really long time.
And deep water wasn't necessarily that deep back then. I think we were in 3,000 feet.
I think it was around 3,000 feet. Yeah, it was something like that. So we had basically developed a methodology for efficiently mooring this rig, combining using analytical tools and our practical knowledge of moorings. And it really just turned out to be a quite successful rig move, and they did it quite a bit faster. So that was our kind of first encounter working together, and it was pretty fun reminiscing about it and thinking about it.
Yeah.
So back to our topic. So we'll start out with what is mooring integrity management. I mean, this subject covers a range of ideas, are interpreted differently by different people, depending on who you ask and what lens they look for. So Kent, why don't you say what mooring integrity management means to you?
Okay. Well, to me, I guess I simply see it as the process of ensuring that a floating asset's mooring system remains safe and reliable and really fit for purpose throughout its life cycle. So in essence, it's a pretty straight, seems like a pretty simple idea, but the process of doing all of that itself can vary depending on the risks and the consequences of a given asset's mooring failure.
Yeah, so I agree. I look at it a bit simpler as I do most of the time. And so it's really making sure moorings don't fail, right? So by checking their condition, understanding the risks, taking action before something goes wrong. So in that though, Kent, so that's the high level definition. You mentioned a process. What do you think a mooring integrity management process should include?
In its simplest form, I think the mooring integrity management process should include regularly scheduled inspections, evaluations and assessments of the data that's collected during the inspections, and somehow reviewing the inspection data to get an understanding of the consequences of the failure and the associated risks. So with regard to the regularly scheduled inspections, you use those to collect information and data like video footage, looking at the mooring components under the water, photographs, and even taking measurements. And when you're doing the evaluations of that data, you're really just trying to develop an understanding of the system's past and present condition and do comparisons to see if it's changing or how much it's changing, so that you can get a sense of how likely it is to fail in the future and how far out it might fail. So that's really the way I see it in its simplest form. So from there, though, I think the asset-specific integrity management strategy in a program can be properly defined and validated.
So, we were talking a lot about inspections there, and, do you think those are all standard, or, are there routine inspections? Are there other times where you do things more complex? I mean, how do you get your mind around that?
Yeah, I think some assets may have consequences of failure that are relatively insignificant. For example, like a standby mooring system where you're just connecting a supply vessel to a mooring system to reduce its fuel consumption. You can always disconnect whenever you need to. If the mooring system failed, the supply vessel is always on standby. Its engines are continuing to run. So there's really no big significant consequence if that mooring system breaks. But conversely, where you're looking at other assets that have high consequences of failure, like oil and gas floating production units, or floating wind farms where there are multiple units moored next to each other, those consequences of mooring failure might be severe to the environment. They might be severe to the floater next door to you in the wind farm case. So there can be more severe consequences of failure. And when that's the case, I think a more rigorous integrity management program is necessary.
Okay, so that makes sense. So I guess the other thing to think about too is if we're dealing with a more rigorous program, we talked about inspections, but let's talk about some of the other elements of that. So we did talk a bit about, calculations of probability of failure. So again, that's looking at how often, a mooring could fail. The other things to consider are the life of the mooring system, considerations if there's life extension going on, and these sorts of things. So, to me then on the practical side, a few things that sometimes people forget is managing the mooring spares. So most projects will have some mooring spares, whether they're adequate or not is sometimes a question, and that should be evaluated. And then I think the other things with spares is, when it turns over from, the capital project, when they're doing the installation, then turned over to the operations guys, sometimes they don't know what the spares are, where the spares are located, what the condition they are. So I think sometimes there's a false sense of security knowing that they have something there, because when it gets turned over, there's not proper documentation, or it's not turned over right. So I think sparing and caring for the spares is a big issue. And then also, looking at it from a mooring repair and replacement point of view. So a lot of these systems go out there and they're trying to, minimize the initial cost of the installation. So they don't really think about, well, what do I need to do if I would need to replace a mooring line or repair it? So there's a lot of expense and time that can go into that in the future if those things aren't properly cared for. So, I think wrapping that all up in something is there needs to be some structure around, what do I do if something goes wrong? How do I deal with my spares and that sort of thing?
Yeah, I agree. And just to accentuate a couple of points there. So on the spare mooring equipment management, we've seen so many cases in the past on projects that we've been involved in where we're repairing mooring systems and replacing broken line components or whatever it might be, where the client knows there's a spare in a yard somewhere, but lo and behold, you find out that spare's been sitting out in the sunshine for 10, 15 years, and it's really not in good condition. So it's effectively not a spare anymore. So that's an interesting thing, that you bring up about spare management. Okay, and as you know, at Intermoor, we've done several incident response plans for various clients. And those really range pretty widely in complexity. We've done incident response plans for individual floating production units. We've done very simple incident response plans where it's nothing more than just a mooring line replacement or repair methodology, using the anchor handler vessel offshore to install a new anchor or hook up a mooring that needs to be replaced. But we've also done more complex ones where the client has a fleet of floating production units and they've just selected maybe 3 different kinds of those floating production units. So one in shallow water, one in deep water, maybe one's a spar or one's an FPSO. And we've done methodologies for representative assets that are applicable to all of their assets. We've also done, more thorough response plans, if you will, to account for all the various kinds of damage or mooring line failures. So how do you respond to a mooring line, and how do you repair a mooring line that's failed up at the top chain near the fair lead versus halfway down the mooring line in the jacketed spiral strand or something, or even down at the low end by the anchor and the ground chain. So we've accounted for that kind of stuff. And then we've also done response plans that help the client. They basically serve as a guidebook to the client, where we collect, contact lists from the client so that when the guy offshore operating the system realizes that something's wrong, he knows who to contact. Who do I call within, the oil company? Who do I call? My boss? Do I call somebody else? Who's going to make what decisions? Because a lot of times decision making in response to a failed mooring isn't clear. It may not be predefined as to who decides what to do and what's going to be done, or when to do it. So it can really be pretty thorough, but it can also be relatively simple.
So I think when you go through that, what comes to my mind when I'm looking at this from the practical sense is, these incident response plans can be a guidebook really tailored to the client and what they need, but essentially, really the whole purpose of them is to correct whatever problem has gone wrong more quickly. So, depending on their competency, where you are in the world, what sparing you have, I think these incident response plans can save you several weeks or even up to several months. So if you look at the scenario, the big one where you don't have the proper sparing and you need a special connector, or you need some more chain, you need to go to the vendor, they need to get that in production. It could be many, many months.
Yeah.
And so even though moorings are redundant, maybe you can keep operating, but in certain cases, maybe you can't operate anymore. So if you're thinking about, these incident response plans can save you several weeks to several months of oil production. I mean, it would seem to me, or I guess this is what we think all the time, it seemed to me the small investment in putting some practical structure around these incident responses is a huge game changer. So, you've got that, big saving in cost, for the production loss. But then also, even if you are still operating, if you can do things quicker and you can do things in a more structured way, there's obviously money to even save on the repair work itself if you're doing it right with the right vessels and the right equipment. So, I think to me it's a huge risk reduction, kind of for the oil companies looking at it that way, and also a potential huge saver in money. So I think with that, that kind of, to me, is looking at how you can do the incident response plans. Kent, maybe one thing to talk a little bit about, because I know you've been on different committees that have written standards for moorings. How are the mooring standards addressing this?
Well, that's an interesting topic. So, I guess I've been on a few of the committees or helped out with a few of the reviewing some of the standards and contributing a little bit to some of them. But I guess one of the things that really caught my attention was years ago, like back in 2000, I think the Mooring Integrity User Group was founded and started as an annual meeting as part of the FPSO Research Forum Week. So that's still ongoing. Every year they have Mooring Integrity User Group meetings, and that's been a really beneficial to the industry type of get-together. It was always encouraged from the beginning, and it still happens, that the operators share more information than they used to. So we've really, as an industry, we've learned a whole lot about, degradation mechanisms, corrosion, pitting corrosion, microbial influenced corrosion, that kind of stuff. So we've learned so much about how mooring systems age throughout their lifetime, and what the causes of their failures can be, and how they degrade. So that's been really interesting. And then as far as, the codes and the standards, there's been a lot of work done towards that. There's been the API RP2I that's presently under review and coming out. So there's a revision to the inspection of mooring systems to make it more standardized and consistent with how risers and subsea equipment are inspected, things like that. There's also been a lot of JIPs, probably I think at least 7 that I could think of or I have on a list somewhere, all focused on either degradation mechanisms or how we can inspect better and get more information. That's led to new technologies for doing inspections. They're even still testing new technologies, for example, on how to do non-destructive examinations of jacketed spiral strand underwater to see if there's any damage to the wires that are within the jacketing, underneath the jacketing. So it's really been several years since 2000 where the industry has really ramped up, in my mind, and matured mooring integrity management and the understanding of degradation mechanisms.
So all those code standards, you mentioned API, there's ISO standards, we know the Class Society all mentioned mooring integrity management. So I think to put a wrapper around all of that, they're all allowing you to use these systems to, guide your inspections. They even have allowances for maybe adapting your cycle times, either higher or lower, depending on what you're finding. But it's all really to the point of looking at things specifically so you can have more reliability. So one other thing I want to talk about, with regards to mooring integrity management is we've done work on floating renewables. So a lot of this talk has been oil and gas, but a lot of this is also, or all of it is really directly relatable to floating renewables. And let's just talk about specifically floating offshore wind. So, we've done many studies, more than 50 anyway in the last few years on floating wind. And it seems to me that the structure of integrity management will really make floating wind better. And that's because it's learning from the oil and gas sector and what we've done, and also to bring some new technologies to the table that deal with the scale of floating wind. So for those that don't know, some of these big floating wind farms will have 20, 30 floaters, even more, beyond 50 in some cases in these big wind farms. And then there's, 3 to 6 mooring lines per floater. So, you're talking hundreds of mooring lines and anchors in a field. And so it can be a bit daunting to think about, how do I build a mooring integrity program? And do I have to look at every single element to make sure I've got mooring integrity? And I think our quick answer is really no, you really don't have to look at every single thing. And this is where a structured program can help you more. And there's newer technologies like digital twins that can help you and bring more insight to the things you're doing. So Kent, maybe from your level, let's not get into the nitty-gritty of everything digital twins do, but from a high level, what is a digital twin, and then how does that impact really the data insight?
Yeah. Well, the word or the terminology digital twin, I think that's also, the industry struggled with that for a while, and honestly I did too for a long time. I guess the most advanced version of digital twins that I'm aware of today, and I'm not claiming to be aware of everything, but it's basically an analytical model of the as-built system in its present condition. And what you can do with that is you can not only say, well, I could run a different environment at the model and see what it can withstand, but even more interestingly is the ability to apply mid-ocean measurements that you've been taking throughout the years to your digital twin model to reassess how much fatigue damage has been done to your mooring system, which may be different if the mid-ocean conditions are different. It may be a different level of damage than what you originally designed it to, based on the mid-ocean conditions that were done during detailed engineering and design work before the asset was actually installed. And in some cases it can be worse, shorter fatigue life due to more damage, and in other cases it can be longer fatigue life. And so that can help with life extensions and things like that. But you can also, so mid-ocean condition measurements can be fed into digital twins, but you can also take measurements of line tensions, line declination angles, if you have instruments on your mooring lines, the vessel motions, things like that. All of that can be fed into analytical models to get a more accurate understanding of remaining fatigue life. Post-hurricane events, for example, if you have measurements of how much the vessel moved, you can figure out how much tension your mooring lines might have experienced and see if there's a significant amount of fatigue damage that happened just due to a large tension spike or a couple of large tension spikes during a severe storm. So they can be pretty sophisticated.
So with that, as you know, our sister company 2H Offshore, part of the Acteon group, has a working digital twin on a wind farm, and it's going to be really interesting what comes out of that. I know we've both looked at some of the early results of that, and I think there's just a tremendous amount of promise for that. And again, I think there's application in oil and gas, but in floating wind, where you have the same type of floater over this field and very similar mooring systems, just that power is magnified due to that scale. So I think it'll be really interesting what becomes of that, because now that we have working models and can see things going on, you can start to see really the applications on how that can increase reliability and decrease costs as time goes on.
Yeah, and that particular one that you're talking about was really interesting because they're actually taking real-time monitoring measurements, and when they were demonstrating their digital twin to us, it was updating every 30 minutes with updated remaining fatigue life or accumulated fatigue damage and things like that. So literally, you can log onto it online and get real-time data and have a nice dashboard with graphs and information that's readily available.
So we could really keep talking about this all day long, and we probably will after this podcast, but I think that's about all the time we have for today. Thank you all for listening. We hope this really has shown why mooring integrity management matters and how staying proactive through these inspections, assessments, planning, incident responses really brings smart, practical decision making to the front, keeps people safe, keep the operations safe, keep the assets safe. So in short, mooring integrity management isn't a task, it's really a mindset. So stay ahead of the problems, not behind them, and join us next time when we dig into more real-world offshore challenges.
Thanks for listening to Act on Energy podcast. To learn more about how we're applying our data, engineering and operational expertise from seabed to surface, visit acteon.com. Don't forget to follow, rate and share. Until next time.